This here is a crappy forge I built a while ago. And I'm going to cut it to pieces and try again. I'm basically only going to be keeping this bowl. That's the bottom of a water heater, mostly because I didn't want to fabricate something like this. It would have been all square and whatever. But I might even ditch that too, I'm not sure. But basically the thing that started this whole, bit of me wanting to mess with stuff, this thing gets hot spots, like really bad. I'll have a spot where it'll freaking vaporize steel, but then other spots where it'll barely get it orange. So it's just like, I don't know. And I want that to be a little more consistent. Also, this intake is shitty, really thin, like ducting tube. And so I bought some of this flexible exhaust pipe to replace that. And another pipe to keep the plastic away from the heat. So basically, first step is I'm going to cut this up and do all that. But first, I kind of want to explain my theory here. So the thing that I'm hoping is going to make this forge work a lot better now with the new ideas I have. Now, I'm not a blacksmith, nor am I a professional forge maker of any sort, but I do work on stuff, like lots of different stuff. One of the things I work on is cars. And cars tend to make fire inside of the engines. I don't know if you guys knew that. And one of the ways they supply air to that fire is through something called an intake manifold. Now, this is a carbureted intake manifold, to keep it real simple. Air comes in through these two holes, mixes with fuel, pulls up in here. In this case, the fuel's the coal, but anyways, just hear me out. Mixes with fuel, kind of makes a cloud of air-fuel gunk, and then these little ports here pull in the air as they need it on the intake stroke, and there's another side for exhaust, but that's out of the exhaust manifold, which is another style manifold, which is more likely what this manifold is going to look like. But basically, if I haven't said the word enough times, I'm going to make a manifold. Now, I'll show you what I got going on right now, and it's not that great. Basically, I have a tube coming up right to the bottom of this forge where there's a hole, and here, I'll just clean it out and show you. I have this pipe that goes down, feeds into a shop vac, and blows air up into this piece of expanded metal. And the reason I put the expanded metal there was because I was trying to create some turbulence. And then on the top, I don't know if you can see that, but I got a bunch of little holes. I'm gonna blow it out here. But the problem is, the area where the air is coming out is super small, and that's not really helping much with the whole, making the forge hot. So what I'm going to do is I'm going to first of all recreate the output part where the air actually comes out, and then I'm also going to kind of create something better than expanded metal to create more air turbulence to kind of get the air to not just blow in one spot, because I think that's the majority of the issue here. Again, alrighty, so this is probably roughly a starting point if you're trying to build a forge at home, I guess. So I just have this bowl-shaped piece from the bottom of a metal water heater. I just cut the top off and used it as a forge. It was a fire pit for a little while, and it still works as one. Now, you can use anything. You just build a metal steel square, something, whatever you want for your fuel, essentially. But right now what I'm doing is I'm cutting a portion. This should, like I said, this should apply to any forge you're building. I'm going to cut out a rectangular section where I want all the air to be flowing out from. So I'm going to figure that out by, how do I want to figure that out? What's a good tool that would likely be doing that? I don't think I'm going to be making any swords. I don't really do that. And if I did, I'd need a bigger bowl, you know what I'm saying? But what would I be making? What's probably the biggest thing I might make here? Maybe a hatchet. This is the port where I stick it in. So, let's say 7 inches. I'll make a 7-inch by 4-inch rectangle. That's what I'll do. What's this? Yeah, that'd be that whole piece in there. So I'll go 7-inch by 4-inch rectangles on a plasma cutout here. I'm gonna mark that out really shittily, haphazardly with this tape measure and marker. So bear with me. Alright, so what I'm going to do here is I got this, I think it's 16 gauge? I don't know, sheet metal. And I'm going to cut out the bottom portion, and it's basically going to be like a rectangular tray almost. That's just the right dimensions. So to mark it, I know it's 12 inches, so I'll go to 14 inches because I want it to protrude down, say about an inch. And that's going to hopefully help with the, maybe I'll do 2 inches. So 16, I want it at 16 inches here. Then I'm going to mark it at 14, and I'm going to mark it at 2. That way, I know where I need to bend it. And it's 5.5 inches wide. So, what's 5.5? 8.5, 9.5? Oh, look at that. That's perfect. So, at 9.5. And then I'm going to mark it 7.5. One, two. Right? Is that right? What does that leave me in the center? 5.5? Yeah, so 5.5 by 12. Perfect. So those are all my marks. You can probably barely see them. I can't really see them very well either. What this guy's for? Well, not the only thing it's for, but it's one thing it's good for. Oops. That's one thing the bottom of a forge isn't good for, is the level works. At least the way I built it. Okay. All the way out here, just because. Then kind of mark this up. And again, I'm planning on filling a bunch of weld here. So, or filling a bunch of gaps with weld here. It's not going to be that hard to do because it's a fairly thick material, but it's not so thick that I'm going to be worried about not fusing, so should be okay. Now I'm also going to mark out where I gotta cut it. Should be, we'll just get a bigger square, how about that? We're at 2 inches. Yeah. That's just a bend mark, so like I said, I'm not super concerned. For my own sake, I'm doing that because it seems like I forgot to do that, even though I didn't. And then here's the other bend lines. Measure this when I'm all done to make sure I'm not off by any margin. Or any too great of a margin, I guess. I want to get it close, it doesn't have to be perfect, basically is what I'm trying to say here. So, got that all marked up with my bends I'm going to do. I'm just going to measure this centerpiece. So I don't know if it's like chicken or the egg, but I never used to work with sheet metal really until I made this thing. I have a video of me making it, by the way, but yeah, I procrastinated on making anything like this for so long because I'm like, I never work with sheet metal. I don't have any fucking use for a sheet metal bender. What the hell am I going to do with a sheet metal bender? But turns out I have a lot of uses for a sheet metal bender. I just needed to have one, and then I kind of figured how many things I could do with it. So this is one example. Maybe not applicable to everybody's case. It's kind of real specific stuff I'm doing here, but. Let me figure something out real quick. I think I need to cut that a little tighter, but I'll get right back to you. Alrighty, so I put the forge back on the little bucket stand, got a magnet holding it there just for the time being. That way I can know how everything's gonna fit up. The plan here, and I'm just gonna be totally honest, and this is a very applicable use of that ChatGPT robot or AI thing. I went ahead and asked it, the AI basically what I should do with this. I gave it the dimensions of this and the dimensions of the top and basically said, what's the best way to get smooth airflow for this application? And I was on the right track, but one thing it mentioned was a transitional piece. And basically what that means is an angle coming out of this hole that kind of sort of starts to widen out a little bit. And what that does is it increases what's called laminar flow, which is the opposite of turbulent air. I kind of want to mix between the two because I want this air to disperse evenly up into this 12 by 5 plate, but I also don't want it to be too turbulent to the point where it's kind of making the combustion inefficient. Now, if this sounds familiar, that's because combustion is combustion, a fire is a fire, whether it's an engine, whether it's, I guess an engine or a fire. It's the only two things I can really think of, but it's applicable. So what I'm going to do is I'm going to make some sort of an angular plate coming up here, and I'm going to have this rise about 3 inches up and then just plate it off, and that'll be the top of the forge. So I'm going to lose a little bit of, bowl depth here. I might not go 3 inches. I might just go like an inch or something, but basically something just to transition so that it's not just from 0 to rectangle, I don't think I'm going to do anything on this side. Maybe a small plate to cover once I'm done doing this piece, but I don't know. We'll see. But yeah, I gotta make a transitional plate, and then the other thing I knew already was a diffuser that's the terminology now I know because I asked an AI. It needs a diffuser piece, which the old design was just a hose sticking up onto this, and on the bottom of the hose it had that. So I already knew it needed a diffuser, and then the outlets or the holes, I just had that sticking right there. And that sucks. That's not really doing anything like special. There's a slight little gap, and that is probably honestly making it a little bit worse. So I'm almost doing the same thing, kind of, but just with a little more like design, I guess. So like I said, I'm gonna have these angular pieces coming up and then a top plate that's gonna be sealed all around here. And I think maybe I'll have some sort of a way for the dust to go down, because this thing does fill with ash and whatnot. I don't know if you can see that, but yeah, I'll maybe even just add a little vacuum port so I can stick a vacuum in there and suck all the shit out with my shop vac. But anyways, here I'll just kind of time lapse me cutting out these little pieces and making this work. I'm gonna use 20 gauge for this, because it doesn't really need to be that heat resistant right down there. This is where the air's coming through, so it's almost getting cooled from the air, The heat's gonna be right on top of that plate, which is gonna be made out of the thicker stuff. Alrighty, so here's kind of the start of the transitional piece here. I'm just kind of wanted to fill you in to give you an idea. I got the hole here, and then that's transitioning to a much bigger hole, and I'm just adding these sort of, I guess, ramps, just to kind of make a more gentle transition here. I still got to tack this down really tight because I don't want a bunch of air being lost here. And then another thing I'm going to do is I'm going to add these little diffuser plates. These ones are too small, but basically I want plates that are gonna, well, these ones are gonna go right here, but if you ever looked up top of your dryer or your fan inside of your bathroom, you might have noticed those weird little fins that kind of come up at an angle and they're stacked. It's like starts the small square and then it's just stacked up that way. It's called the diffuser. Basically what that's doing is the air is hitting that central point and it's being disrupted and then disrupted further and then disrupted further, and what that does is that motor's probably got an inlet that's like about that big, but it's got to disperse it over an area that's the size of your entire like floor vent or roof vent. I mean, those are usually square. This one's a rectangle. It kind of looks like a floor vent. So I just wanted to tell you that to kind of give you an idea of what I'm going after here for that air diffusion. And I'm going to basically add probably, say 1, 2, 3. I'm probably going to add 3. So a total of 6 plates, just to kind of get that air to really spread out. And then I'm just going to put a plate on top of this that's just got a bunch of holes in it. That way the air kind of flows through those holes evenly. Ideally. I mean, granted, I don't know if that's how that's going to work, but based off of what I've researched, the minimal research I've done, that should work out just fine. my utter refusal to spend any money on material for stuff like this. I will only use stuff that's scrap from other things that have made me money. But, you know, that's just me. If you're just a, you know, regular old Joe that doesn't have problems like me, you might be able to just, you know, buy brand new stuff and make this look nicer. Alright, so here's this nonsensically perforated porous plate that I just made. I was trying to say something funny there, I just kind of gave up. A lot of P words. Basically what the idea is I just want the air to be very dispersed over all the coals that are on top of there. That way I can have a much larger surface area that's got a lot of heat, especially for heat treating, because one of the biggest issues with the forged design that I had before was when I finally go to do arguably one of the most important parts of making, say, a knife, it doesn't heat it evenly. And, you know, when you're heating it up and just beating it, shaping it, that's not a super big deal. But when it comes to heat treating, like for hardening and tempering and stuff, I don't temper on this forge, but when it comes to heat treating for hardening, that does turn into a little bit of a pain in the butt. So what I wanted to do is hopefully negate the majority of those problems by making, like I said, a diffuser system here. So it's not super complicated and there's no propane coming out of here. It kind of looks like a propane grill though. I got that inlet here. This is going to have some sort of a gap in the middle here, and then it's got this sort of a TP or triangular shape. That's going to force air to come out from the sides, and then it's going to allow a little bit through the middle. And then my theory here is that's going to hit this, kind of force the air out more, but still allow a little bit through here. But the path of least resistance is going to be here. So the whole concept I'm trying to do here is just to get the air to be even over top of, because it's coming out of a 2-inch hole. Literally, it's like, I mean, maybe even smaller. It's coming out of a shop vac. Alrighty, well here's that ugly plate on the bottom, and I got much more surface area that's getting air. I just need to add that inlet pipe to the bottom since all the interior intricate stuff's done, and then I'm done with this forge. I can go ahead and fire it up and give it a test run. So, definitely going to put gloves on because all of this is sharp and half of it is hot, so not really a great thing to be grabbing raw-handed, you know what I'm saying? Where the hell did my other glove go? Right over here. Alright, so let's put her in the hole. If I can. Oh shit, that's heavy. Okay. Oh, it's not balanced either. Woo. Oh, motherfucker. Yeah. I'm not really setting a good example for anybody on YouTube here. You shouldn't do shit like that. There's no reason. Called somebody to help or, you know, whatever. But I'm impatient, so I did it myself. Alright, so I got the shop vac going, blowing air, and I'm just going to show you my little not-so-scientific way of figuring out whether I'm getting this even. I'm just feeling it with my fingers right now, and it feels like it's dispersing pretty well. Directions, but it is consistently flowing over the entire surface of this. So I would call this a win. Went ahead and mounted the bowl back onto the upright that I had made earlier. I basically reused the majority of the stuff from the original forge I had made. But the biggest part of this video, I hope that you took away, was this little manifold is what I'm going to call it. Now, any old forge you're going to build, coal forge, with the little tiny bit that I know about them, because again, I'm not a blacksmith, I've made probably 5 or 6 knives with this, and then a couple of different tools for specialty things, but not much. I'm still very, very new to smithing. Anyways, I do know that even distribution of airflow is going to make a big difference in how the metal heats up, and it's going to make everything a lot more even and a lot more controllable. At least all I got to do is move the piece of steel, you know, because there's going to be fuel. The whole thing's full of fuel. It just needs to supply air in the right location. So hopefully this is going to make all the difference. Now, anyways, I hope this video was useful, or at the very least entertaining to you guys. I hope it helped you out and maybe encouraged you to try this out if you do want to get into blacksmithing. It's really, really fun, and it's not that hard to start, especially when there's really no pressure to do anything perfectly. It's not like somebody's hiring you to do it. So yeah, hopefully this gets you guys more confidence to try this out. And other than that, I really do hope you enjoyed the video, and if you do, please like and subscribe. And other than that, have a wonderful rest of your day. God bless.